Hi, in this video, we'll talk about trigonometry. This is part 2, and it's mainly about solutions of triangles. When I mean solution, that means that we have to find the angles of the triangle or the length of the sides of the triangle or length and the angles together. Anyway, trigonometry is a branch of math that deals with triangles, particularly right-angled triangles. Why? Because right-angled triangle is a very, very fundamental figure. Using this right-angled triangle, we can form any triangle, or we can form rectangles and other polynomials. Trigonometry deals with relationships between the sides and the angles of triangles, and with the trigonometric functions which describe those relationships. In previous videos, actually, to study this course, a student should have some idea about basic trigonometric ratios, right, in a right-angled triangle. That is how actually those things are defined for acute angles. And just to recap, some of them is, number one, is definitions of trigonometric functions. That is prerequisite to this course. And that is if you're given any right-angled triangle, right? And we know that what is sine of alpha? It is opposite side over hypotenuse. Cosine of alpha is defined as adjacent side over hypotenuse, and the tangent of alpha is defined as opposite side over adjacent side. And this is what we mean by the definitions of trigonometric functions, let's say for acute angles. And accurate values of trigonometric functions for special angles. What we mean by special angles, we mean 0 degree or 15 degrees or 30 or 45 or 60 or 75 and 90. And by using the identities in similar way, we can obtain the exact values of trigonometric functions for the angles for 120, 150, and 180 degrees. Anyway, and the trigonometric identities, okay, and the extended law of sine. Let me just write here. One of the most important identity is the first one. Actually, it is, what is it? It is sine square root of alpha plus cosine square root of alpha is always equal to 1. One of the most important one. Extended law of sine. Actually, sine rule says that if you are given any triangle, and this ABC are sides, and the capital A, capital B, capital C, these are corresponding angles, then these ratios are equal. A over sine of A is equal to B over sine of B is equal to C over sine of C, and which is equal to 2R. What is 2R? It is a circumradius. That means that if you draw a circle, okay, and all of the vertices of the triangle are lying on the circumference of the circle, this R is the radius of the circle. Circumscribed circle, we just call this circumscribed or inscribed circle. Inscribed is inside the triangle. Circumscribed means that all the vertices of the triangle are lying on the, what is it, the circumference of the circle. Just one example is, let's say this is our circle, and let's suppose that we are getting even any triangle. Here, let's say this is our triangle, Okay, let's say this side vertex is A, and this one is B, and this one is C. Okay, and this side is A, this side is B, and this side is C. That's what we talk about. And suppose that this one is actually, it is the radius of this circle. Okay, so law of cosine, that is, if you're given any triangle, okay, and this ABC are the size of the triangle, and this capital A, capital B, capital C, these are corresponding angles of the triangle, then these relationships are always true for any triangle. A squared is equal to B squared plus C squared minus 2BC cosine of alpha. That's the angle included. B squared equals A squared plus C squared minus 2AC times cosine of B. And C squared is equal to A squared plus B squared minus 2AB cosine of C. These are just some of the very important concepts or in trigonometry, that actually all of the things are taught in the first part of trigonometry. Now the second part, you're using this one, we're going to solve a few questions. Okay, again, once again, solution of triangle, what we mean by this in trigonometry, to solve a triangle is to find the angles and the length of the sides when some are given but not all of those information. Okay, some are given. For example, let's say in this case, let's say if B and C is given, alpha is given, how do you find the length of A? Okay, or all angles are given, one side is given, how about can we find the remaining sides of this triangle? This is what we mean by solution of triangle or solving a triangle in this course. At least let's start with this example. In this example, in a right angle triangle ABC. So this ABC is a right angle triangle. Immediately I can just draw here this small square, which shows it's a right angle. Angle B is 90 degrees. D is a point on BC such that AD bisects angle A. So that means that these two angles, they are equal. These angles are equal. Okay, and also BD is given. BD equals square root of 6. So this BD is square root of 6. And DC is equal to 2 times square root of 6. The question is find the length of 3 sides. Okay, this side is, let's say it is C, and this side is, what is it? It is B. Let me just write here B. The question is, we have to find B and C. So solution. Now, if I draw this dashed line, okay, if I just draw D to E, okay, so what is it? Square root of C. Actually, this one is B. Okay, it's not 6. And number one, we can find the relation between C and B. Okay, since it is an angle bisector, right? Using the ratio of angle bisector, we can write this ratio, the C over square root of 6 is equal to, and 6, not 6, it is not 6, even I'm confused here, it is B. So this one is, it is B. So B over 2 times square root of 6. Now from here, square root of 6, square root of 6, they cancel each other. What do we get here? So B is equal to 2C. Okay, that's the first step. And the second one is, since ABC is a right angle triangle, I can use Pythagorean theorem to find the value of B and C. Pythagorean theorem says, what is it? A squared plus B squared is equal to C squared. So here the shorter size, BC, what is it? It is 3 times square root of 6. So 3 times square root of 6 squared. And the second shorter side, that is C, C squared is equal to B squared. Now we have this equation, but 2 variables. Since actually we know B in terms of C, if you substitute there, 3 squared is 9. 9 times 6, here we have 54. Plus C squared. Instead of B, substitute 2C. So 2C squared, that is 4C squared. So from here, 3C squared is equal to 54. What is C? It's 54 over 3 is equal to 18. So that's equal to square root of 18. Or 18 is 9 times 2. That is 3 times square root of 2. If it is so, then what is B? B is equal to 2 times C. That is 3 times square root of 2. That's equal to 6 square root of 2. So dot, dot, dot. C equals 3 times square root of 2. And B is equal to 6 times square root of 2. So we have to find the side length or length of the remaining sides of this triangle as set. In example 2, it says in an acute angle triangle ABC. That means that all interior angles are acute angles, less than 90 degrees. Suppose that BC is equal to A and CA, capital A, is equal to B, and AB is equal to C. And angle A is equal to 60 degrees. So this angle is 60 degrees. Okay, find the value of C over A plus B over A plus C. Okay, A, B, C. So to do this one, okay, let me draw a height or altitude from C to AB. So the CD is an altitude. So this angle is 90 degrees. Okay, so if it is so, then at the time, this angle will be 30 degrees. Okay, so since it is B, okay, this AC is B is a hypotenuse. If you remember the relationship between 30, let me just rewrite one more time. And here, if this one is a spatial triangle, this angle is 30 and this angle is 60. If this side is A, the hypotenuse should be 2A. It is 4A, it is 8, right? So this one will be square root of 3 times A, because A squared and the plus 3A squared, that's equal to 4A squared. At the time, if it is B, right, the hypotenuse, opposite side of this angle 30, this is AD. What is AD? Then AD will be half of the hypotenuse. So that's equal to B over 2. Okay, and how about this square root of, the CD, that's opposite the 60 degrees, that's equal to square root of 3 times B over 2. That is square root of 3 over 2 times B. And how about DB? Since AB is equal to A, the remaining part DB will be equal to A minus B over 2. Okay, so now using this CDB, the triangle CDB, it's a right angle triangle. I can just write the relation how A and B are related to each other. Okay, so if you just write the Pythagorean theorem for the triangle, what is it? BCD. Let me just write here triangle BCD. Okay, what we have here? Here we have square root of 3 over 2B squared plus A minus B over 2 squared. So that's equal to A squared. If you expand the left-hand side, here we have 3 over 4B squared and A minus B over 2 squared, that is A squared, minus 2 times A times B over 2, that's equal to just AB, and plus B squared over 4. On the right-hand side, we have A squared. So this A squared is gone. 3 over 4, B squared plus 1 over 4, B squared is equal to just B. So what do we have here? Here we have B squared minus AB is equal to 0, which means that here A must be equal to, what is it? B. That's our first observation. If we didn't make AB is equal to C. It's not A. This one is C. Gosh. This one is C, not A. Okay, so at the time, this will be C. Okay. So here we have C squared minus BC plus B squared over 4 is equal to A squared. So this is gone, right? Actually, 3 over 4B squared plus B squared over 4, that's equal to B squared. And plus C squared minus BC is equal to A squared. Okay. Or I can just write this anyway. You can just take this B minus BC to the right-hand side. I can just write here A squared plus BC is equal to b squared plus c squared. Okay, that's actually the first part of our solution. Let me just write here number 1. And how about the second part? Um, the second part, so we have to find this expression, right? C over a plus b plus b over a plus c. So now if you just express this as a single denominator fraction, a plus b times a plus c, that's equal to a squared. And here we have ac, b times a, it is ab, and b times c, it is bc, right? A plus b, a plus c, b over a plus c. So now here we have c times a plus c, that is ac plus c squared. And b times a plus b, that is ab plus b squared. So now instead of this b squared and a squared, right, I can just write, here we have ac plus ab, and instead of this ab, what is it? A squared, okay, b squared plus c squared, that's equal to a squared plus bc. So that's equal to a squared plus bc. I'm just using this expression here. Over, here we have, let me rewrite this one as ac and ab, and here we have a squared plus bc. I have just rearranged. See here, the numerator and denominator, they are the same expression. So which is equal to 1. So dot, 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 the value of the given expression must be equal to 1 under the given conditions. Another example, example 3. In a quadrilateral ABCD, AB is equal to 3. Okay, and CD is equal to AD, and angle B equals angle B, which is equal to 90 degrees. And tangent of angle A equals 2. Find the length of BC. So here, first, let me just label the given things here. So ABCD, AB equals 3. So this AB is equal to 3. CD equals AD, so they are equal to each other. And the angle B, that's equal to 90 degrees. And also this angle is 90 degrees. And tangent of A. So tangent of A, this angle, right, is 2. Okay. So what is CD? I don't know. Let's say it is A, and also this should be A. Okay. So find the length of BC. So we need to find BC. Let's say it is X. Now, since it is 90 degrees, if I just extend the line AB and CD, they will meet somewhere here. Let me label this by E. Okay. So now from here, this remaining part, okay. So since this solution, this tangent of A, what is it? Tangent of A is in the right angle triangle, opposite side, right? Opposite side is EC plus A over adjacent sides. That's A. That is equal to 2. Now, if you just solve this here, you will get that EC will be equal to A. So now this EC is equal to A. Okay. So that means that is 2A, that is alpha. And if, let's say this angle is alpha. So this angle is, let's say it is beta. Okay, this alpha plus beta is 90 degrees. So since this angle is 90 degrees, then this angle should be alpha. All right. So now if you look at this, we have 2 similar triangles. Okay, 2A, do I know that's, okay, X, no, okay. So what are those similar triangles? Triangle, let's say BCE, triangle BCE is similar to triangle D, and the angle C is alpha. So it is DAB. So these two triangles are similar. Okay, which means that we can write the ratio BC over DA, right? BC, what is BC? BC is equal to X over DA. What is AD? That's equal to A. Equals CE. What is CE? CE is equal to A over AE. AE is equal to 3 plus BE. 3 plus BE equals, and BE. What is BE? BE is equal to, I don't know, let's say this BE over DE. And DE is equal to 2A. So now, first I can find the relation between X and the BE, right? If you look at the first ratio and the last ratio, X over A is equal to BE over 2A. Now from here, we can get that X over A is equal to BE over 2A. So this AA cancels each other. From here, what is BE? BE is equal to 2X. So this one is equal to 2X. Okay. So now if it is equal to 2X, so now we can find the relation between A and X then. Okay, number 3 is, look at the triangle BCE in BCE. So 2x squared, 2x squared plus x squared is equal to a squared, because a is a hypotenuse. 4x squared plus x, that's 5x squared. 5x squared is equal to a squared. Now from here, what is a? A is equal to square root of 5 times x. Okay, so we need to find BCX, right? And so now we can just use the biggest, what is it? Triangle, and we can get, what is it? The value of BCX. So the last part is, let's say the last part is, in a big right angle triangle, here we have a squared plus 2a squared is equal to 3 plus 2x squared. Okay, so on the left hand side we have 5x squared, right? So that's equal to 5 times, what is x squared here? I mean a squared here. A squared is equal to, let me just write here, square root of 5 squared, that is 5 times x squared. On the right hand side, here we have 9 plus 2 times 3, it is, 2 times 3 times 2, it is 6, 12. Here we have 12x. No, I think I don't have to solve like this, okay? So that is 3 plus 2x, 3 plus 2x, because I know that x is positive, right? If we just take the square root of both sides, square root of both sides, on the left hand side, we have 5x. On the right hand side, we have 3 plus 2x. So from here, x is equal to 3 over 2. So what is x? It is BC. So dot, 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 BC is equal to 3 over 2. Okay. Another example. Example 4. In triangle ABC, sine of A, the ratio of sine of A to sine of B is equal to square root of 2 to 1. And C squared plus equals B squared plus square root of 2 BC. Find the sizes of angles A, B, and C. So the solution, I don't know what kind of thing is it, okay, but still, just to visualize it, we can draw any kind of triangle. Say this is our triangle, and this say is A, and this one is B, and this one is C. Okay, so that means that sine of A, right, opposite sides. So this one is square root of 2A. Okay, and sine of B, so this should be just A, something like this. Actually, if I write A, it will be a bit confusing. So it's a ratio. That's why if it is K, okay, this side should be equal to K. And also it's given that C squared equals B squared plus 2 square root of 2 times BC. Anyway, now from here, see, we can find the relation how this A, I mean the side B and side A are related to each other. And see from here, what is from here, sine of A, right, is equal to square root of 2. Let me just write it like this. Sine of A over sine of B is equal to A over B. That's equal to square root of 2 over 1. Now from here, we can see that A is equal to square root of 2 times B. That's our first finding. Okay. And I think we know how actually things are related to each other. So number 2 is, we know that if I use, for example, cosine theorem, right, the C squared will be equal to A squared plus B squared minus 2 times A times B times cosine of angle C. Okay, let me just write angle C. So that's equal to B squared plus square root of 2 times BC. Now from here, this B squared, they cancel each other, right? And take this minus 2AB cosine of C to the right hand side. And okay, BC. Otherwise, I think this way we cannot simplify this. How about if I use A squared? Because instead of A, I can write B. How about A squared? A squared is equal to, here we have B squared plus C squared minus 2 times BC times cosine of angle A. Okay. So now A is equal to square root of 2B, right? So if you substitute here for A, square root of 2B, that's equal to 2B squared. On the right hand side, we have B squared plus C squared minus 2BC cosine of angle A. So now take this B squared to the left hand side, we have B squared, right? And so at the time, take 2BC to the left hand side, what we have here. Okay, here we have 2 times BC cosine of A is equal to C squared minus B squared. And also from the given information, C squared minus B squared, that's equal to square root of 2 times BC. And also that is equal to square root of 2 times B times C. So now these two things, right, they are equal to each other. Square root of 2, actually BC, they cancel each other. From here we can get that cosine of A is equal to square root of 2 over 2. Okay, which implies that an angle A, right, is equal to 45 degrees. If angle A is 45 degrees, then immediately I can find the size of angle B. And the third one is, what is it? The third one, using the first expression, sine of A, right? Because if A is equal to 45, what is sine of A? Sine of A is also 45 because we know the sine of A is equal to cosine of A. So from here, then sine of A, that's equal to, what is it? Let me just write here. From the first given expression, sine of B is equal to sine of A over, right? Sine of A over square root of 2, the first given ratio. What is sine of A? It is 1 over square root of 2 over square root of 2, which is equal to 1 over 2. And we know it's a special angle. From here, angle B is equal to 30 degrees. So now here, what is angle C then? Angle C is equal to 180 minus A minus B, which is equal to 180 minus angle A, 45, angle B, 30, 75, which is equal to 105. So now we have actually found all the angles. Angle A equals 45 degrees, and angle B is 30 degrees, and angle C is equal to, what is it, 105 degrees. Example 5, in triangle ABC, A is equal to 11, B is equal to 25 units. The radius of the circumference is 125 over 8. Find the possible values of A. C. Let's use green here. So since we know that again by using the sine law, right, actually A is given. So from here, A over sine of A is equal to 2 times R. I can write B over sine B or C over sine, doesn't matter, just I want to use this one. So what is A is equal to 11. And sine of A, I don't know, is sine of A that's equal to 2 times R. What is R? That is 125 over 8. So that's equal to 125 over 4. Now from here we can find sine of A. So sine of A is equal to, here we have 4 goes up, that is 44 over 125. Okay. So now from here, sine of A, I can find cosine of A, but what is the question here? Find the possible values of C. Okay, so we have found A. The second thing is I can find the cosine of A, right? What is cosine of A? Because if I know cosine of A, then we can find C. Because here we are talking about this kind of triangle. So this is something like this. Okay. And suppose that this is side A and this one is B, this one is C. Okay, this one is actually angle C. And this one is vertex A and vertex B. So A is given, right? A is given. Actually, even I don't have to write this A. Let me just write here it is 11. And how about B? B is equal to 25, is equal to 25. And now if I know C, right, we can find also the length of this C. So how can I find C, angle C? Using this trigonometric identity. We know that the cosine of A is equal to square root of 1 minus sine squared of A. That's equal to 44 over 125 squared. So which is equal to, in the numerator, we have, what is it? 125 squared minus 44 squared over 125 squared. And if you just evaluate this, A squared minus B squared, that's equal to A minus B times A plus B. So this will be equal to 117 over 125. Okay. So that's the value of this cosine. So now number 3, we can evaluate C using the cosine rule. So what is C squared? C squared is equal to A squared, that's 11 squared, plus B squared, that is 25 squared, minus 2 times 11 times 25 times cosine of A. Cosine of A is 117 over 125. So which is equal to, if you evaluate this, okay, 11 squared plus 25 squared minus 2 times 11 times 25 times 117 over 125, which is equal to 1156 over 5. Now from here, dot, what is C? C is square root of the answer. That's equal to ABC. I made a mistake here because cosine of A, it is not angle A. We know cosine of A, right? So from here, I have to use this one. A squared, that is 11 squared, is equal to 25 squared plus C squared minus 2 times 25 times C times cosine of A. Cosine of A is 117 over 125. Okay, we have this expression. So now if you simplify this, what we have here? Here we have C squared minus, and 25 it is gone. So it is 234. So 234 over 5C, right? And plus 25 squared, that is 25 squared minus 11 squared, that's equal to 504. That's equal to 504, that's equal to 0. We have quadratic equation. Or if you multiply both sides by 5, so here we have 5C squared minus 234C plus 5 times 504, that's equal to 2,520. That's equal to 0. Okay, now there's a quadratic equation. We have to solve this. How do you solve this? Maybe by factorization. If you factorize, we can write it as 5C, because that's the only way. 5C minus 84, and here we have C minus 30. That's equal to 0. You can check this. 5C times C, 5C squared, 5C times 30 minus 150, and the 84C, 84, that's their sum is 234. And 84 times 3, that's equal to 252 with 0. So dot, possible values are C is equal to 30, or C is equal to 84 over 5. Okay, that's it. Now we're going to solve questions from the exercise 1. We have, I think, around how many questions? We have 10 questions or 11 questions. Let's see. As much as we can. Let's start with question 1. Solution. An isosceles triangle ABC, AB is equal to AC, and that's equal to 25. And BC equals 14. Find the value of sine of A. So here we have, we just draw any isosceles triangle, and this one is A, and this one is B, and this one is C. Okay, AB equals AC. So this side is equal to this side, and the length is 25. So that's 25, also that's 25. And BC is equal to 14. BC is equal to 14. We have to find the value of sine of A. And since it is so, actually these angles are equal. Okay, so let me just draw an altitude or height from A to BC, perpendicular. If you do a perpendicular, right, since an isosceles triangle, also this side should be equal to this side. That will be 7. Also, this should be 7, right? Now from here, I can find height. No, it's not the right method, I think. I should not do this. Okay. So since we need to find sine of A, let me find cosine of A. Now from here, then we can find sine of A, right? So using cosine theorem, 14 squared is equal to 25 squared plus 25 squared minus 2 times 25 times 25 times cosine of angle A. Now, if you solve this for cosine of A, what is cosine of A? Cosine of A is equal to 25 squared, 25 squared. That is equal to 2 times 625 minus 14 squared, that is 196, over, we should divide it by 2 times 25 times 25, that's equal to 2 times 625, which is equal to, so that's equal to 2 times 625 minus 196 and divided by 2 times 625, which is equal to 2 times 25 squared, okay, and minus 14 squared, okay, over 2 times 25, okay, it's correct. So that's equal to 527 over 625. Either using Pythagorean theorem or what is it? The identity of the trigonometry, we can find the value of sine of A. All right. So now let me just use Pythagorean theorem. So if this one is our right angle triangle, okay, and let's say this angle is A. So this side should be 5 to 7, and this side is 6 to 5. What is cosine sine of A? Opposite side over adjacent side. So I just need to find this x. From here, what is x? X equals square root of 6 to 5 squared minus 5 to 7 squared. So that's equal to square root of 6 to 5 squared minus 5 to 7 squared. That's equal to 336. Actually, I can just use the algebraic identity. Here we have a squared minus b squared, that is a minus b times a plus b. So we'll get 336. So from here, then dot, sine of a is equal to opposite side, that is 336 over hypotenuse, that is 6 to 5. Another example question. Okay. We use this color for this. In triangle ABC, angle A equals 30. Angle C minus angle B equals 60. If BC is equal to A, find the length of AB. Now first, let's just find the angles. We know that in a triangle, angle A plus angle B plus angle C is equal to 180 degrees. What is angle A? It is 30 degrees. And what is angle B? Is angle B. And how about angle C? It is angle B plus 60 degrees. That's equal to 180 degrees. Now from here, if you just solve this, we get that 30 plus 60 is 90. 180 minus 90 is 90. 2 times b is 90. What is b? B is 45 degrees. Now what is angle C then? Angle C is 45 plus 60. That's equal to 105 degrees. Okay. So if BC is A, BC equals A, find the length of AB. Okay, now actually our triangle is something like this. Okay, let's say this point. So this one is angle C. Okay, so this one is angle A. So vertex A, and this one is vertex B. All right. So now, if you actually label these angles, this one is 30, right? This angle is 30 degrees, and this one is 60 degrees. And C is 108, 105. So now, what is BC? BC is, it is A. And AB is equal to, let's say, this C. So we have to find C. Now let me draw a height. Okay, if I draw a height from C to the sides, okay, so this 30, so this angle will be 60 degrees. And this angle will be 45. No, if it is 90, 105, right? No, B is 45. Why? It's not 60, it's 45. So this angle will be 45. Okay. So if it is A, right? So this is x squared and x squared, this h. So we can find A. What is actually BC? And this side is equal to this side. It's not drawn to scale, unfortunately. So this will be A over square root of 2. And also this side will be A over square root of 2. Because A squared plus A squared over 2, that's equal to just A squared, right? And if opposite side is A times the 30 degrees, right? It's confusing here. So if A over square root of 2, so this hypotenuse AC will be 2 times A over square root of 2. That is 2 over square root of 2 times A. Okay. And how about the opposite side? The opposite side, I mean, the side which is faced by the angle 60 degrees, it will be square root of 3 times this angle. That is A over square root of 2. Okay, this is the 30-60 degree relationship, right, in the right angle triangle. Now we need to find BC. Now from here, AB. What is AB? AB is equal to A over square root of 2 plus and square root of 3 over 2A. Right, square root of 2, which is equal to, here we have, anyway, you should just write as 2 square root of 2A, square root of 2, 6A. Okay, we can just do it like this. Here we have A times, here we have 1 plus square root of 3 over square root of 2. Okay. We can simplify this further, multiply by square root of 2, because usually we just keep a whole number or integer in the denominator. At that time, we will have square root of 6 plus square root of 2 over 2 times A. That's the length of AB. Question 3, solution. In a right angle triangle ABC, BC equals A, CA equals B, and AB equals C. Angle C is 90 degrees. Okay, let me just draw any right angle triangle here. Okay, this is our right angle triangle. And this one is angle C. Okay. And what is it? Let's say this A, and this one is B. It says that BC is equal to A. So BC is equal to A, and this side CA, it is B, and this hypotenuse, it is C. And also it's given that A plus C equals 6. So A plus C is equal to 6. And also it's given that tangent of A, right? What is tangent of A? Tangent of A is opposite side, that is A over B. That's equal to square root of 3. Okay. So immediately from here we can get this relation. That what is A? That A is equal to square root of 3 times B. And solve this triangle means that we have to find the, what is it? The length of A, B, and C. Okay. So A plus C is equal to 6, right? And immediately I can just write the Pythagorean theorem and try to express everything in terms of one variable. A squared plus B squared, that's equal to C squared. Okay. Now from here, instead of A, I can write square root of 3B. So here we have square root of 3 times B, right? That's our A, plus, how about B? B is equal to just B squared, okay, is equal to, and here we have C squared. Okay, C squared, instead of C, I can write 6 minus A. What is A again? Square root of 3 times B, and here we have squared. Now we have an equation in only B. On the left-hand side, square root of 3 is 3B squared, and one more. So here we have 4B squared. On the right-hand side, 36 minus 2 times 6 is 12. Square root of 3B plus 3B squared. So we have a quadratic equation. Is a good idea or not? Okay, let's see. Take everything to the left-hand side. Here we have B squared plus 12 square root of 3B minus 36. That's equal to 0. Actually, again, I think since we know that B is positive, and we don't have to do like this. So on the left-hand side, we have 3 and 4, 4B squared, right? So 4B squared is equal to 6 minus square root of 3B squared. Now, if you take square root of both sides, here we have 2B is equal to 6 minus square root of 3B. Or what is B here then? Dot, dot, dot. B is equal to, take to the left-hand side, 6 over 2 plus square root of 3. Okay, or if you just multiply numerator and denominator by 2 minus square root of 3, so at the time here we have 6 times 2 minus square root of 3. Okay, that's B. Okay, then that's it. Now I can write all the solutions. Dot, dot, dot. A is equal to square root of 3 times B. So that is B. And inside the parentheses, square root of 3 minus 3. And B is equal to 6, 2 minus square root of 3. And how about C? C is just 6 minus A. That is 6 minus A. That is 6, 2, square root of 3 minus 3. And we can just simplify this and write this, and that's it. Question 4. Solution. In triangle ABC, BC equals 6, AC equals 6 times square root of 3, angle A is 30. Find the length of AB. Okay, so let me just draw any kind of triangle again. Let's say suppose this is our triangle. Actually, it's really hard to draw. Okay, and suppose that this angle is 30. Okay, and that is angle side A, and let's say this B, and this one is C. And BC is equal to 6. AC is equal to 6 times square root of 3. And the angle A is 30. Find the length of AB. Let's say this side is X. So we have to find X. What do you do here? You can just use the cosine theorem, right? 6 squared is equal to X squared plus 6 times square root of 3 squared minus 2 times 6 times square root of 3 times X times cosine of 30. So now if you simplify this, here we have 36 X squared plus 36 times 3, it is 108 minus 2 times 6 times square root of 3 times X times, what is cosine of 30? That's equal to square root of 3 over 2. So now these two to cancel each other, and write this in standard form. It's just a quadratic equation, minus, and 2 to cancel each other, square root of 3, square root of 3, this 3 times 6 is 18. So here we have 18x, and plus 108 minus 36, that's equal to 72. That's equal to 0. So it is 18. So 2 times 36, 4 times 18, 6 times 12. Right, actually we can just write as minus 6 minus 12 minus 6 minus 12. So I can factorize that x minus 6, x minus 12. That's equal to 0. So this x is equal to 6, or x is equal to 12. If x is equal to 6, it should be 30, 30, 60, 120. If x is equal to 12, okay, there will be any contradiction? I don't think so. So find the length of AB. So that's equal to 6, or it can be 12. Okay. Anyway, another question, solution. In a right angle triangle ABC, angle C equals 90 degrees. D is a point on BC such that AD bisects A. Prove that AB minus AC over CD is equal to tangent of BAC. The kind of questions, okay, with letters, it may be a bit confusing. So let's just simplify this problem. Suppose that this the given right angle triangle, and this one is C. So that is C, okay. And let's say this B. Let's say this A, and this one is B. So it says that D is a point on BC such that AD bisects A. So we are talking about this angle bisector. Okay, this angle is equal to this angle. They are equal. Okay, prove that AB, let me just label this, okay? AB, what is AB? AB is equal to C. And BC is equal to A. And AC is equal to B. And also BAC is just angle A, right? So what we have to prove is AB, that's equal to C, minus AC, that's equal to B, over CD. CD is equal to, let's say this point is, it is D, right? So CD, let's say this A1, and the remaining part will be A minus A1, right? So anyway, let me just write A1 because it's a part of A, and this part, let's say this A2. So here we have A1, that's equal to tangent of angle A. So we have to prove this. Is it true or not? Also, let me label the things. So this side is B, this side is C. Okay. Now, using the angle bisector theorem, okay, let me just write the first step. So from here, I can write this relation. B over A1 is equal to C over A2. Or I can just write this. A2 over A1 is equal to C over B. Or if you just add 1 to both sides, okay? If you add 1 on the left-hand side, I have A over A1 will be equal to C plus B over B. Okay, that's our first finding, C plus B over B. Now the second step. So we have to find C minus B over A1, right? So using angle bisector, second one is, what is tangent of A? Tangent of A is equal to opposite side, that is A over B. Okay, so now A over B. Okay, we have to show that that's equal to C plus B over B. Okay, so now A over B, we have to show the C minus B, right? Okay, so that's equal to, let me multiply numerator and denominator by A. So here we have A squared over AB. And since using Pythagorean theorem, what we have here, A squared plus B squared is equal to C squared, or A squared is equal to C squared minus B squared. So this, instead of A squared, I can write C squared minus B squared, over, instead of this A times B, right? If you just cross multiply, what is A times B? That's A1 times C plus B. So instead of AB, I can write here A1 times C plus B. So if you factorize the numerator now, that's equal to C minus B and C plus B, over denominator A1 times C plus B. So now C plus B, they cancel out each other. So that's equal to C minus B over A1, which is equal to, what is C? C is equal to AB minus AC over, is equal to CD. So that's proof is done. Okay, let's have one more question and finish today's class. In quadrilateral ABCD, angle B is equal to angle D, and that's equal to 90 degrees. Angle A is equal to 60, AB equals 4, AD equals 5. Find the ratio of BC to CD. And again, just to draw this nicely, okay, let me draw my right angle triangle because it says 90 degrees, right? So it's a part of this quadrilateral. And here we are just drawing this kind of thing. And because angle B, angle D. And suppose that this one is angle D. Let me just write in boom. And this one is angle D. So this one is angle B. So at the time, angle A, so this is angle A, that is 60 degrees. Angle A, B, and this one is, it is C. And we just extension, okay, ABC, and this will be E. Just extend it. Actually, here we are given the quadrilateral ABC. And also it says that AB is equal to 4. AB is equal to 4, and AD is equal to 5. And what is it? That's it. We have to find the ratio BC to CD. What is BC? BC, let's say it is X. CD, it is Y. The question is, what is X to Y? Right? BC to CD. That's the question. So now, since it is 60, this angle should be 30 degrees. If it is 30, this angle should be 60 degrees, right? Opposite side, it is 4, right? Then what is EC plus, actually, if the opposite side is 4, right? The hypotenuse should be 2 times 4. So it is CD, AD is equal to 5. So ED should be equal to, it is 3. So if it is 3, right, opposite side is 30, right? It is Y. It is 3, then what is Y? Y should be equal to, no, not Y. Actually, okay. Opposite side, okay. All right. So in this small triangle, what is tangent of 30? Tangent of 30, that's equal to opposite side, that's Y, over adjacent side, that's equal to 3, right? And tangent of 30 is sine of 30, that's 1 over 2, and cosine of 30, square root of 3 over 2, which is equal to 1 over square root of 3. Now from here, what is Y? Y is equal to 3 over square root of 3, or simply square root of 3, okay? Now, from here, what is sine of 30? Sine of 30 is equal to opposite side, Y, over hypotenuse, that is EC. What is Y? Square root of 3 over EC. Now, from here, what is EC? EC is equal to square root of 3 over sine of 30, which is equal to 2 times square root of, because sine of 30 is 1 over 10. 2 times square root of 3. So this EC is equal to 2 times square root of 3. Okay. So that's it. Now from here we can find X and we can find their ratio. Okay. So actually without also finding this, we can find the ratio, but somehow I started, that's why. So now, what is tangent of 30 again? Tangent of 30 in a big right angle triangle. Opposite side, it is 4 over adjacent side, that is 2 times square root of 3 plus x. So that's equal to 1 over square root of 3. Now, if you solve this, that x will be 4 times square root of 3 minus 2 times square root of 3, that is 2 times square root of 3. Now, from here, dot, the ratio of x to y, x is equal to 2 square root of 3 over y is equal to square root of 3, that's equal to 2 to 1. That's all for today. Thank you very much.